Welcome to episode 329 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing okay. Getting ready for the holiday season.
Yeah.
Yeah.
If you're ordering Christmas presents, you need to order them today, I think.
I think I'm all done with my Christmas shopping. Are you done, or you still got more to do?
I think I'm done. I'm pretty sure I'm done.
That's good.
I actually started a couple months ago. I'm like, ooh, I'm going to order that before I forget about it. So,
Okay. Well, at the top of every episode, I like to read a piece of feedback. We got a lot of great feedback from last week's episode. It was a lot of fun talking to Kate and Guy. This tweet's from Rob Bernstein saying, "This episode was fantastic. I didn't want to turn it off. I love the interaction between the four of you and all the journeys into different topics. I've pre-ordered the book. Can't wait to dive in." So, yeah.
we got a lot of
to
feedback on Twitter for that
We had a
one.
lot of good feedback. The one thing we did get also was the most Reddit comments on any post ever, I think. But it
Oh,
was not about the show at all.
I saw a
It was
comment.
like
Yeah.
200 posts of just someone ranting about Rust versus C++. That had nothing to do with the episode.
That sounds great.
Yeah. So I was a little sad to see that there were that many comments that had nothing to do with the show. But
So, welcome to the
we got
internet
lots
kind
of
of
good
moment.
feedback, though.
Yeah.
Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Daniel Ruoso. Daniel is the manager for code governance at Bloomberg with a focus on driving large-scale static analysis and automated refactoring. Daniel's been working the past 20 plus years with a persistent lens on how to help engineers be more effective with build, deployment, and analysis tooling on various different environments and languages, with a more recent focus on bringing C++ modules to a state where they can be used by more people. Daniel is a Brazilian music nerd and will talk endlessly about that if you let him. He also plays classical guitar. Daniel, welcome to the show.
Thank you for having me.
Yeah, welcome. How large is the code governance team, if I might ask?
So we have around 25 people between full-time employees and contractors. We have a static analysis pipeline that runs around 20 projects per second, running various tools across the entire code base that we can see.
Wow.
So it's been a journey. We have a lot of tools that we write in-house for specific refactorings, for getting rid of old dead code, for feature switches that are considered fully deployed, and for removing blockers for migrating to newer platforms and those kinds of things. So it's been a wild journey.
Wow. Sounds like that's pretty crazy.
Yeah. Also joining us today is Brett Brown. Brett is the team lead for the Bloomberg Build Tools team, focusing on compilation tool chains, build systems, and large-scale code migrations. Brett likes improving C++ software development by treating projects more like cattle and less like pets. In October at CppCon, Brett presented a talk on CMake modules and co-presented a talk on packaging C++ with Daniel. Both Brett and Daniel are active participants in the ISO tooling study group. Brett is a lead and founding member of the C++ Guild at Bloomberg. He contributes to Bloomberg working groups on C++ tooling, testing, conferences, deprecations, and ISO engagement. Brett, welcome to the show.
Hey, glad to be on.
Can you give us the elevator pitch on what you mean between more like cattle and less like pets?
Yeah, I mean, it seems like, and there's a lot of reasons for this, but it seems like a lot of C++ projects people treat as a special thing, and then
Right.
they end up adding special build rules, special like directory layouts, all sorts of things. And at the scale we're operating at Bloomberg, like Daniel was talking about, like that gets to be really, really expensive. And even at a smaller scale, if you have a side project, you probably don't want to sink a lot of time into just keeping things running, right? So really what people want is something a little more regular so that they can use the same CI pipeline on all their projects. They can use the same analysis techniques. It works with all their IDEs. And a lot of the bespoke things that people add are actually the things that get in the way of that. So a lot of what I focus on in my free time, my fun projects are ways to get those kinds of pain points out of the way to let people have all the features they want without having to bake those features into the physical project they're working on, if that makes sense. So my talk about CMake modules is, for instance, a technique to get your bespoke CMake out of your project and have that live as something you can reuse across your projects.
Right.
Very cool. All right. Well, Brett and Daniel, we got a couple news articles to discuss. Feel free to comment on any of these. Then we'll start talking more about the work you're doing at Bloomberg with modules and everything. Okay. All right. First thing we have is a new version of Boost. It's always worth mentioning these. This is version 1.78, and lots of changes to ASIO file system, Boost Beast. I don't think there's any new libraries here, are there?
I didn't see any new ones, no. Yeah, no new libraries added.
Yeah. Anything in particular anyone wanted to point out in all these change logs?
I think it's interesting there's a breaking change to way regexes are parsed.
Oh, I missed that. That's interesting, yeah.
Capital B versus lowercase b as per Perl behavior. That's kind of fascinating because I mean there's like a lot of Boost regex code out there right now, right? Like if one of the projects that I'm working on, I might still use Boost regex. I think we may have moved it to standard regex. I'm not sure now. But if it's still using Boost regex and if it had this in here, it might be a while before that was noticed that it broke a parsing in some of our code.
I'm not too familiar. I don't know regex well enough to know what this breaking change means with /capital B or /lowercase b. I don't know what that means.
/b is the word boundary.
Okay.
And then capital B would be not a word boundary, right?
Okay.
So just like lowercase s is any white space, capital S is any non-white space.
Okay, I gotcha.
So they're changing to make it look more like Perl or less like Perl?
More like Perl is what it seems to be, yeah.
I got a confession to make. Like I'm a long-time Perl guy.
That's so you speak like Hubert, basically. I also find it interesting that there's so many changes to ASIO because, we've talked a lot about the possibility of standardizing networking and like with the reluctance to ever break ABI in the standard, but it does seem like, something like ASIO it's a moving target. Like, I mean, they're constantly updating the network libraries and it just makes me question, does networking actually have a place in the standard or not?
Yeah, there was a conversation on C++ now in 2019 where we were talking about this idea of adding graphics library to the standard, and at some point, like I was making the comment, do we really want a GCC to depend on Xorg or Wayland?
Right.
And it's kind of like a ridiculous proposition on the face of it, but I understand why people want it because the lack of package management in C++ means that the only way for you to reasonably do this in a way that's not full of bespoke solutions is to actually put it in the standard. I guess since we don't have a package manager, I guess everything has to go in the standard so we can do it in a uniform way.
Yeah, even for less controversial features like threading support, we've actually had problems like adopting them at Bloomberg using standard stuff because there's implicit dependencies between your stable standard library and things that are significantly less stable, like 1TBB, right?
Mm.
Yeah, libtbb does not have any ABI promise at this point. So if you're using execution from C++ 17 and you ship your executable in a non-containerized environment, it's very likely that you don't know that you risk breaking at runtime.
Right.
All right. Jason, do you want to talk about this next one? Because this next news item is coming from you, right?
It is coming from me. Yeah, I spent for like 5 years now since I've been teaching object lifetime classes. I have these exercises for my students that everyone seems to have some fun with. And so I thought, what the heck, I'm going to go ahead and make it into a full-on puzzle book. So I just released my first puzzle book. It is called Object Lifetime Puzzlers Book 1, which implies that I plan to release more than one of them. Did any of you have the chance to look at this at all, by the way?
Yeah, I'm really bad at these things.
Okay.
Like there's those Twitter posts about what does this do, and I'm always
Oh,
wrong.
no. Let's be clear. No. This is explicitly not Shafiq's polls. Okay.
No.
These are fun.
These are fun. Well, it was
These are
fun. So I did. I turned on The Sound of Silence by Simon and Garfunkel, and I started doing the puzzle. And I got, be sure to drink your Ovaltine. Is that the right answer?
You're right.
To the sample you had? I think that's right.
Yeah, that's right. Yeah. So if you actually do get the book, like I do recommend people get the print copy of it because it is a puzzle book and you want to write in it. It actually does explain. It covers automatic lifetime, static lifetime, dynamic, and thread local object lifetime. And it's all just like sorting out when does an object lifetime end and when does it begin? When does it begin? When does it end? And then you fill in the puzzle, and it explains it all along the way. So my niece, who's actually visiting at the moment, happened to be here right when the proof copy came from Amazon. So I just handed it to her. She has absolutely no experience or interest in programming at all, and had to ask 2 questions from me, and then just tore into it and spent like the next 3 hours doing the puzzles. She had like a lot of fun with that.
That's really neat. Yeah, I mean, we hit this stuff, like these are the kind of edge cases we hit when we're upgrading a compiler. And like the compiler subtly changes.
Right, so all of these things,
there's always a trigraph involved. I mean, not a trigraph, a ternary, like a ternary operator involved for some reason. But yeah.
Well, it shouldn't. Anything that happened, like if you're not talking a global static, then your compiler was broken previously, because these things are well defined. That's the point of C++, right?
Yeah.
So
I'm not arguing with you. a lot of times our bugs are like this is weird edge case, and it's not. It was broken before, and now it's hopefully less broken now, but it's still kind of broken, but it's changing.
Or it's broken in a different way.
Yeah,
none of these straddle the line of edge cases. They all work on all compilers. It's all verified code. So
that's good, though.
Record.
Maybe we should pass this around Bloomberg. One of the migrations we're doing is to get rid of the other kinds of statics you were just talking about in the code base.
The global ones.
Maybe we should we start passing this around Bloomberg. It's like, do these things instead. Because that's what we need. We're like, okay, if you want static lifetimes, these are the defined things. Stop putting them in the top of your header files and stuff like that, right?
So I did actually, for the record, it intentionally meant this to be fun. So hopefully at least some people have fun with that. Like I said, I know non-programmers can have fun with it. My actual concern is that C++ programmers aren't going to have fun because they're going to question everything that's in there. And trust me, it is all well-defined behavior. Like, just get that out there. I even had one of my patrons almost immediately be like, I don't think that's defined behavior. I'm like, yes, it is. I've been teaching this for 5 years. It is. But C++ programmers don't trust the compiler. People who aren't programmers just trust the rules that I put in the book.
All right.
Anyhow.
Yeah.
Right.
Cool.
The person probably even started with actually.
No, they didn't. All my patrons are really cool.
Okay, and then the last thing we have here is it's a blog post from Kevlin Henney, who's definitely a great guest we had on a while ago. And this is, he's kind of having a take on Agile and how maybe we're not tracking the right things with Agile. Does anyone have a better description of this one?
So I've been using Agile for like a really long time. Like I started with extreme programming back in like 2001. Kind of thing, and this has consistently been the hardest thing to explain to people, that like the point of us measuring those things is not to make it go faster. The point is to make sure that when I'm talking to the customer, that I'm saying, we think that we're going to deliver this in 4 weeks from now, that I'm actually going to deliver that 4 weeks from now, and that it's better to say I'm not going to deliver than to say I'm going to deliver and not do it. And this is like consistently the thing that people get wrong when thinking about Agile, is just thinking that the point is to go faster. But in my experience, the main point is to be predictable.
Makes sense.
I think it's also good that it Agile helps you think about, where am I going? Am I still going the right way? Right? You have like the little checkpoints to do that sort of thing. And the sprint, the point, as he says in the article, isn't to be fast and sprint per se. It's to have those shorter increments where you're thinking, okay, what about now? Am I doing the right thing now? And not wait a month, a year, or worse to decide, oh wait, that whole time I was just wasting my time. I should have done something else. So his analogy to vectors and mathematics was really effective. I thought that was a good way to explain it. Like you want a vector that has a long magnitude in this thought experiment, but you also want it to have the right direction, right? That's the point of a vector. It's not just, so if you're talking about how fast are you going in a two-dimensional space or something, right? It doesn't matter where you're pointed. It's not just how long the arrow is that you're drawing or something, right? So, and that goes for software projects too. Like, are we going the right way? Okay, now let's go in the right way is way more important than going fast, right? Because you can go fast in the wrong way and end up worse off than you started. So that was a really good point.
Yeah, and if we're doing this, continuing the analogy that you made, that you're making there, we also kind of want to find what the unit vector is to get that predictability.
Yeah. That's a good point. I didn't think about that.
I have a standard rant on this conversation. If you go to my LinkedIn, you'll find this article. Can put a link somewhere later, I guess, on how most people miss the point of Agile. And I think this article was really interesting in bringing that point.
Very cool. All right. So Bret and Daniel, I guess what's a good place to start? Because you have been working on, switching to modules at Bloomberg, and it sounds like you've kind of faced some challenges, have some ideas for things that might need to change in order for others to properly use modules. Is that right?
Yeah, I guess we could start chronologically.
Okay.
Well, I guess from Daniel and my perspective. In the last few years, we've had really good success going to a more standard, more regular build system, treating our projects like cattle, et cetera, at Bloomberg. We've been using CMake as a core technology for that. We've been engaging with Kitware on certain kinds of CMake enhancements. I was doing some research, and Daniel was jumping in too on, okay, well, this module stuff seems cool. I see these articles about how we're almost ready, or we have this branch in this one project where you can maybe do modules with your build system. So I was approaching it from like, okay, what do I need to do? What do I need to plan for the next year to 3 years or something for like, okay, how do we get modules running when our compilers are caught up at Bloomberg, right? And I didn't see the places to hook up to implement a build system to do modules the way we need to do them at Bloomberg. In particular, I didn't see the way to integrate the layer between packaging and building. Is a very important layer. It goes both directions. Like, you pull in information from your environment to build, and then you provide information to the destination, like as a package when you ship, right? And that information wasn't there. Like, what is like your dependency? You depend on a module. You say import foobar. What does that mean? Where you go to some file system somewhere. There's some interface source file somewhere. You compile it somehow. Like, that information wasn't there. And then in the standard, to be fair, doesn't say anything about any of this. It talks about what goes inside of your source file. In fact, the standard doesn't say it's a file. It just says it's, a translation unit, right?
And it was very explicit about not saying these things, right?
Right.
Okay.
So the challenge we're concerned about is like, okay, I don't know, as someone that does a lot of this, how to get modules working at Bloomberg, basically, right? So Daniel took the lead on writing a paper, and that's P2409, if I got the number right, to kind of describe what we're worried about and why we think we're kind of blocked to even get started on that. And a lot of that gets into the details of what I was just saying there. And so that paper was presented to Study Group 15 at ISO, the tooling working group, Study Group, sorry. And we've done subsequent conversations since, and that's probably a good introduction, I think. There's a lot to drill into exactly what the problems are, which use cases are not supported yet, and maybe where we can go with that. But I think that's a good intro.
I think there is one like iconic aspect of this, which is that most people that are not involved in the modules conversation or implementation think that part of the implementation that is happening is that there's going to be like an interoperable format where you can ship like a module file as like a pre-parsed thing that anyone can consume, and so it's going to be super fast because you don't have to parse that anymore. But the reality is that with the exception of Visual Studio, the scope of compatibility for modules right now is the same for the module interface. The binary module interface files right now is the same as the scope of compatibility of precompiled headers, which is kind of like literally the same compiler binary. Like even a different build of the compiler may result in it being like an incompatible format.
Oh wow.
So that when we have those conversations, like I always say that we have a lot of these like oh moments where it's like you explain some things and it's like, oh.
Yeah. like how would you call cling tidy on with a dependency that comes from your system? So let's back up a second. Bloomberg, when it ships packages, uses almost exactly what you've probably seen already in Linux distributions. We use, just normal Linux style package management. You would install a library on your system. Your build system would know how to find that library in your system using either a combination of conventions and maybe some metadata, like package config or something like that, right? So that's what we do at Bloomberg. Part of the reason we're escalating this is because it's clearly not a Bloomberg specific problem. Like everyone's going to have this problem. And we were kind of wondering, why isn't anyone talking about this? I thought people would have issues open on this problem or something. And so that's why we're trying to, talking about it, making sure people to raise awareness about, we didn't want to do packaging in C++ standard yet, at least. But we got to figure out some kind of packaging standards, really, or at least when it comes to shipping precompiled libraries that contain modular interfaces. So anyway, so go back to cling tidy. So let's say you installed a package like Boost, right? And you want to build, but you want to analyze your code, right? But that code says import boost.filesystem, right? Your cling tidy is more or less, for the purposes of this conversation, a compiler, right? But you don't necessarily have a build system, right? Most people point at a compile commands.json file or something like that, right? But that compile commands.json file is describing how to execute with whatever your production compiler is or whatever your local development compiler is, which probably isn't cling tidy. It's maybe a different version of Clang at best. It could be GCC, could be ICC, could be anything else, right? So those compile flags are not compatible between compilers. And there's no, like Daniel was saying, there's no standard metadata that's precompiled sitting on the machine that all those different tools can go look at to say, okay, what's inside this module? What are the declarations? What are the classes, et cetera, right? And keep in mind that modules can have pound includes in them. So you also need to have all the classic old flags of preprocessor definitions, include search paths, things like that. So like that's a use case for, okay, well, how do we get cling tidy to work? But it goes for everything. Like, how does your IDE know, like what's inside that module? How does your other analysis tools? There's and again, like how do you get different packages in a in a directed graph of dependencies? How do you get those packages to know, okay, well, this thing is exporting that interface from this other module as part of its interface? Like you have to go walk the transitive graph to find like all this metadata for everything.
And we have a particular interest in making sure that we can do that without a very tightly coupled integration into the build system. Like I talked before about how we do like 20 projects per second static analysis. We can do that because we extract only the information about translation units through like an image that we send through like a distributed compute platform that executes all those static analysis. But now, if we're saying that you need to integrate this deeply into the build system because the build system needs to tell cling tidy how to produce the different module interfaces, because your compile command just receives the path to the BMI that is compatible with that compiler. So how do you go about like introspecting a build system from the outside to be able to run a static analysis tool if the only thing you see is the path to the BMI that's compatible to this compiler?
Right. I mean, another way to phrase that is in the real world, you often have to use multiple build systems in parallel, maybe spread out over time, to build a C++ project, like all in all of its dependencies, right? So these build systems need to have an interoperable format to say, okay, I'm a build system and I provided this module pre-built, here you go. And then some other build system can say, oh, okay, you have this module and it has these classes, I got it, right? But like that's something we don't have. So that's what Daniel's second paper is about how to just kind of describe that broadly and importantly also how to discover that. Like, okay, so there's a file in the system now, in the second paper at least, that's proposed. There's a file in the system now. It has some properties of a compile commands.json file, and that'll have like include directories and stuff. And it has some properties of a package config PC file, and that it's kind of discoverable. You can model a directed graph of dependencies. You can discover the dependencies without having to transitively declare all of them in your build system, which is something that people struggle with now, which is like, okay, so you want to add this library. Well, guess what? You have to go find all of its transitive dependencies and add them also to your build system. And that's a real pain in the neck. And that's something, again, it's pets not cattle. And worse, like the people you're depending on can't change things anymore because that breaks your build, because now you pinned a thing that they didn't pin and it's horrible, right? So anyway, so that's the problem we're talking about.
So everything is terrible.
Yeah, it's just a lot of work. It's not, I want to make sure people realize there's a lot of work. There's plenty of room for people to come in and try things out, implement them, share their use cases. We're talking about this in the SG15 mailing list. That's something people can ask to subscribe to, and they can see some of these conversations. We've been beating the bushes around the community, trying to get more people from relevant parts of the C++ ecosystem involved in these conversations in the scope of SG15. We've had some good success there from different kinds of vendors that provide packaging, vendors and other organizations that provide packaging systems, provide build systems, that provide
tool chains,
yeah. But like, to some degree, like if the impact on this, other than a lot of these things are breaking, like one of the things I'm also concerned about would just be what happens if one of the vendors figures out that's something that really works really well for them, and then another vendor finds something else out that works really well for them. And then we, Bloomberg, have to figure out a third thing that works for us. And then guess what? We're like, do modules really work at that point? Like on paper, at the language spec, sure. But in practice, as an end user, like if you're doing a training class and you say it's really easy, if you want to do modules, you just do import foobar, and then there's this 10,000 lines you need to add to your CMake list. It's really easy, right? And you have to hard code all these flags for all the things you ever pull in. Like part of the point of all this is that we start getting out of that habit, like, and just pushing it into the build system isn't really a solution. So we kind of need to come up with a way to kind of describe these things.
So you all have mentioned like a bunch of different compilers and a bunch of different build tools so far. And just out of curiosity, like what are you actually focused on? Are you using GCC, Visual Studio, CMake? Is that your main concern? Like, where's the focus?
All of the above.
Okay.
Like we have like I said, we have a Linux style distribution basically.
Right.
We take open source projects as tarballed and released by them in most cases, and maybe with patches as few as possible. We'll actually build those and provide them to our engineers. Okay. So like we do have a few, I mean, you name it. We probably have at least a few projects using that build system, for example. As far as toolchains go, we mostly target Unix, Linux systems, although some of our teams do support Windows in different ways. We don't want to be necessarily pinned to that subset of the ecosystem forever. Like it is nice to have the option to do more Windows or to ship to Macs or something at some point, right?
So GCC recently says that they support the C++ 20 modules, but Clang is still doing Clang style modules, or is that difference affecting you all?
Yeah, we're using pretty stable compiler builds right now, so it's not even, it's more of a medium to long-term goal that we would even use modules at Bloomberg like seriously.
Okay.
Yeah.
Okay.
So this is me staying ahead of my concern is like if we don't start working now, like we're going to be talking about a decade or two at Bloomberg, right? Not just like waiting for GCC or Clang to catch up to some feature list.
Okay, got it.
Yeah, our main concern is not necessarily the compiler support, although that is absolutely necessary for anything to happen. But the main thing is how do we make it actually work when actual people are actually typing in their editors, kind of thing.
Actual people involved. That's
Yeah.
if you remove those from the equation, I think this would all be much easier.
Yeah.
And the compilers, right?
Yes, and remove the people in the compilers. We have no problems.
Yeah. So I mean, and we're right in the gear house of like, hey, this is exactly the kind of organizations that should really benefit from modules. Like we'll have
Right.
really deep dependency trees. It'd be great not to have to pre-process like all the world just to do a hello world kind of thing. It'd be nice to include IOStream without blowing up your build times exponentially or something, right? But like it's like, well, if I can't put it in the build system, it doesn't matter though, right? So yeah.
So are you getting kind of good feedback from the committee with these papers? Are others recognizing this as a problem?
Yes. Short answer is yes. The long answer is the awkward part about this is that a lot of the problems that modules have is because C++ decided to do things backwards and decided to do 4 modules before doing package management. And a lot of that awkwardness and the parts where we don't have consensus right now is precisely on whether we should compromise for, like, can we just make modules work? Because the second paper, the P2473, it is about let's make modules work with the ecosystem as it is now. And the place where we don't have a consensus is that a good idea? Like, shouldn't we just push ahead and actually fix the underlying package management problem, which would be great. And I started some conversations in the SG15 mailing list and with some people in other package management systems. But it's an immensely complex problem to solve. So I'm not super confident that if we put order of operations to be first package management, then solving modules, that will not have like something usable like before 2030 or something.
So the half a loaf we're shooting for, or a quarter a loaf, or however much of a loaf we're talking about, I guess, is like maybe we can start with initial standards for, not a standard, that's the wrong word, because again, an ISO, that's a special word that means special things, but a document describing what a package would look like for a C++ project, which no such document exists. Like, what is a package? Like, is this a good package? Could you look at a package and say, this has the stuff you need to be a C++ package? Forget where it comes from, forget how it's compressed, forget how you download it, forget what its name is. But if you looked at it, does it have the minimal amount of metadata possible, right? And that's not something that has been done before, as far as I'm aware. It should be really good for the package management system, ecosystem, and maybe someday it could be something we build on to make an actual package. I don't know if you ever have a package manager. At least it'd be nice to at least have interoperable packaging such that you enable the new package manager instead of port to it, if that makes sense. Because that's kind of the experience right now. It's like, okay, you have to, okay, I'm going to port to Conan, or I'm going to port to VC package, or I'm going to port to, make build so I can go to, Arch ecosystem stuff. Like, it's a porting kind of exercise, just like going to a new OS or something, right?
Yeah, if we could get to the point where we standardize, and again, standardize is a complicated word. If we have an interoperable format, if we normalize the way that package managers communicate with build systems, if just that language becomes more interoperable, like, we would be like a huge step forward, right? Because build system would have, instead of having to export a package config file, a CMake export file, Conan file, you would be able to just export this one language, and then other build systems would be able to read that language and be able to consume those libraries. But even that, like, when you start talking, like I was talking with Tobin from this PAC project, and he deals with all the HPC world, which is way more complicated than I ever thought could be, and like all the ABI zoo that they have makes this any serious attempt of answering that question way more complicated than one would expect. And the thing that that is really the challenge here is when you look at folks using a system like we do, for instance, which is like a simple package management deployed with Linux file system hierarchy standards based deployment, package config is kind of good enough, right? Like you have -i's, you have -l's, you have -d's, and that's okay. So it's a really hard lift to say like, oh, all these people that have a really like convenient solution that works well for them because they have a very specific scenario, that's not good enough. You got to go to this very much more complicated thing, because in order for us to normalize things, you need to take care of the use cases that you don't care about.
Right. And the use case that's the simplest is, okay, just throw everything into the user include directory and hit the build button, right? Like that in particular is just not going to work going forward. Like, 'cause again, the build system actually has to model the graph of the things you depend on instead of just say, here, compiler, here's a -i flag, have fun, right? So I think it's, yeah. Again, actually, we didn't actually make a fine on this detail, but again, Daniel kind of over it, but the big thing one of the big things we want for modules is that you don't have to go parse that code over and over again, right? We want to say, I parsed that once, maybe even like an hour ago. I just grab it. I don't want to reparse that, right? For that to work, you need a file on the disk somewhere or a database or something that has that information cached. For that to exist, your build system has to tell your compiler to make it. So, and for that to work, again, you have transitive dependencies. The build system has to be able to walk the graph and make sure all those files exist. So you're building things that aren't in your project, but not as textually included into your source file. That's something that's new here. That's something people sometimes ask is, what's new about modules? Why isn't this a problem already? And that's one of the answers is like, well, we want to be able to only build the one time. And so to build only the one time, you have to know when to build the one time. So you have to know so you have to say like, oh, I don't have a binary module interface file for Boost file system. Make one, put it in your build directory, and we'll use that going forward. And like Daniel said, depending on if you have different compilers, you might have to have a set of those and know which one to pick. And worse than that, depending, like we still have textual inclusion because especially C libraries and stuff will have that. So you still need to, tweak those if somebody has slightly different -d flags or something. So we'll need like checksums to know, like, this is not the one you want. You want this other one that used the -d something equals 1 instead of -d something equals 0, that kind of thing, right? The good news is like all that should be cleaned up over time. But like in theory, at least as long as you're not including C APIs too much, but so there's a lot of work here. I liked a lot of work coming out of the talks I saw at CppCon in October. There are a lot of great talks, a lot of cool things about, hey, we can use concepts this way and that way. A lot of them kind of had this implication like, yeah, this will all be header only kind of now if you do it this way, but we'll have modules someday. So when we have modules, like we don't care about header only anymore, right? It's all just a module interface. It's still private. You don't have to worry about leaking your stuff into other people's ecosystems or blowing up their compile times, right? Because modules will solve that. It's like, well, yeah, maybe if we could get adoption at a certain scale. And that's kind of what Daniel and I were talking about. Like, okay, well, how do we actually get there? What's the roadmap? So we're kind of flexible on the roadmap to some degree, but we would like to, like we just talked about with the Agile thing, it's nice to take little steps if you can instead of try to boil the ocean up front. I'm not opposed to boiling the ocean if we could all get on the same page about boiling the ocean, though, I guess.
Sounds like an ecological disaster, though.
Yeah. Well, I guess we are kind of boiling the ocean slowly, aren't we?
Yeah, slowly getting there. Okay, I just want to take like 2 steps back to make sure for like my own sake here that I'm...
Please, yeah.
Okay. The current state of the art for modules means that if I want to use modules for my work right now, I have to rebuild that package on my system with my compiler, with my flags to get that module. And then then I can use it moving forward. And there's simply no way to distribute these things to anything other than my specific build configuration.
Right. The current state of the art is there are a few build systems, and I think Build 2 is advertised as being one of them. In CMake, there's some branches that people are doing research on. And maybe you can whip up your own, Gmake version of your own thing. Daniel has an example of how you might do that in his second paper, P2473, right?
Okay.
Anyway, the current state of the art is, and these are the kinds of things you see in the talks about modules and like, hey, look at the compile times I got. They're so much better.
Right.
You have one build system and it knows about everything. So if you are certain famous large software companies and have all your code into a big monorepo, you might be fine.
Right.
Or even if it's not in a monorepo, but every repo gets built in the same system in a single workspace.
There's one build system that knows how to build everything. So like if you use CMake has a feature called fetch content in which it actually will go get. If you did that for everything, actually you might be okay, assuming CMake knew how to within a CMake build like map these modules to each other. It gets difficult when you have to jump into another build system context, and that could still be the same style CMake, but just a different build directory given. If that makes sense. Like it's enough that you had a different process modeling the mappings between things, right?
A substantial part of the first paper, 2409, is actually making the distinction between this, what we call source-to-source dependencies versus source-to-binary dependencies, where the idea that you have different projects that can introspect the source tree of each other and be able to pass information from one build system, for build system to know about information from one source tree to the other source tree, versus environments like ours or like every Linux distribution, where you essentially have these separate steps where you build a project, you generate the built artifact, you deploy that artifact, and now you consume that artifact from a different build system without knowing the original source tree or anything. And that's where the adoption of modules is right now. Like all the testimonials that we have of module adoption right now are in the environments of what we call like the source-to-source dependency environment, where the single build system can see the entire thing, and then it can build the entire graph and it can run the entire build.
Right. All of the issues you're discussing, I was just trying to place my memory here. I believe Izzy Muerta was bringing up a lot of these issues in like 2018.
Yeah.
And I hadn't really heard anyone talk about it since then. So a part of me was just going, oh, cool, someone solved these problems and now I don't have to worry about it. But it doesn't sound like really anything happened.
That's my guess as to why we're not talking about it. Is everyone's like, oh, we got those people are so smart. Izzy's like, Izzy knows everything. Yeah, if Izzy's on it, I'm sure it's fine, right? And yeah, I can't explain it, so that we're just like, hey, let's start a conversation. And so that's where we ended up. We're like, why is anyone talking about this? We would ask around, like, have you been talking about this? Have you been talking about this? Like, why isn't there a paper for SG15? And someone said, well, nobody wrote the paper. We're like, oh, okay. So you want a paper? Okay, we could do that, right? So Daniel did it, but I said we.
I mean, we can't underestimate the impact that like 2020 had on everything. So I think that probably played a huge role there too.
Yeah, that's probably fair.
So have you proof of concepted any of these like specific, like you have a proposal for what a normalization of these things might look like? Have you implemented those?
So I have in that paper, the second paper.
Yes.
So let me clarify one thing. So we talked about normalizing package management, and we talked about the quarter loaf solution, as Bret stated, of just making modules work with the current ecosystem. Mm-hmm. So the paper 2473 is actually trying to achieve the latter, which is, let's see how we can make modules work in an environment that looks like the environment we have today.
Right.
And the way that looks is we essentially have a proposal where modules kind of look like header deployments, where you can map the module include through like a path on the file system. You have a search path, and you have a specific translation from the module name to the path on disk. But then because modules have the separate parsing context for the module interface unit, and by that I mean the -i's for the code consuming a module don't have to match, or I should even say shouldn't match the -i's of the parsing of the module interface itself. And so this proposal includes what we call a meta IXX info file that describes here's how you parse this interface. And then the proposal also comes with a convention on how to name the BMI file. such that if you find the file with that name, you know it's compatible and it's the right one. And then if you don't find it, you can just use like GNU makes vpath to say, oh, it's not here. I'm just going to produce my own, and now I can consume that module. So in the process of writing that paper, we actually wrote a little like toy project using GNU make that's linked from the paper to exercise and show, look, we can make this work with GNU make. We just need this couple extra steps to generate like the module dependency, which would essentially be like a C++ modules config utility that scans the module search path, looking for the dependencies and building the entire graph, and generating what I called like a modules config.json, and then a separate tool that, for the case of this toy project, was the C++ modules make, which would essentially generate the rules for producing all those BMI files that you would need. But this is all with like a mock compiler and mock parsing.
You could do that, probably. You just want CMake or something to know how to do all that. So we're also talking to Kitware about like how can we get that going, or could we try this out? Hopefully someday there'll be something published in that space. But
I was just going to ask, like, have you gotten much feedback from build system implementers or compiler implementers on some of these proposals?
Yeah, we work pretty closely with Kitware in particular because we use so much CMake, and they're the core maintainers of CMake, if people didn't know.
Yeah.
So yeah, we've sponsored some work in there in the last couple of years for different things that we've saw with like quick wins, especially in just general CMake workflows. Like, I don't know, some easy ones to explain would be environment variables you can set for like CMake build types, so you don't have to just add -d CMake build type to every stupid compile command you do in the whole. You can just say, just environment, put in your .files, stop setting it, it's fine.
Yeah, we've seen some of those in the more recent releases. Notes come up. Yeah,
some of those are Bloomberg sponsored because we're like, again,
that's cool.
Pets not cattle. I don't want to have to go to all my CI setups and add the -d whatever to every single one of them, right? That kind of stuff. So we're talking to them about modules. There's Kitware people in the SG15 meetings, keeping tabs on things too. So as far as that goes, we're pretty confident we'll figure something out there. There are other build system implementers in the SG15 meetings. They haven't objected, saying I could never do that. I could never implement it. Not yet, anyway. Okay. I wouldn't say every single person that's ever worked on a build system or cares has been in the meetings. So I would encourage people that care a lot about build systems to at least subscribe to the mailing list and provide feedback in other channels, even if you can't make the meetings.
I guess the other question I have is, sorry, just real quick. Does this require like actual ISO buy-in, or is it just something that the different compiler vendors, build system vendors, kind of need to agree on to like have?
That's a good question.
A set of standards. Yeah.
There's a long answer, but the short answer is ISO doesn't really do specs for build systems or packaging systems or anything like that. So Daniel kind of said earlier, like the best we could do is publish a report saying, hey, we polled and we all think this is a paper that you could read, right? And we like it as a paper that you could read. I guess like I'm not an expert on ISO workings and how all that works. Possibly you'd need like a whole nother ISO group to just be like build systems, C++ build systems versus the language. But that might be a different guest could give you a better answer to that question. But that being said, like, yeah, so I mean, the real end goal, if we're talking about like outcomes versus like the Agile things, what are we actually where are we actually going here? But you're right on the nose. Like the real thing is we want to know that the ecosystem is going to be there, that they're at least not saying I'll never do it. At least like if you really like, we would live with if you twisted my arm and you donated time or money or volunteer work or something, I guess we can make that happen. A lot of times that's something that people need to struggle with as engineers, because we like the perfect, the pristine, like let's get all perfect and then we'll ship it. And a lot of times what we really need for these kinds of consensus driven things is, yeah, I can live with that. Like I'd sleep fine at night if that's what was happening. And that's kind of what we're shooting for. That's the expectation. Some people will be perfect, I'm sure, but like we want nobody to be it. We want everyone to be at least in I can live with it. And that's actually really important, right? Because anything short of that, and we start ending up fracturing the ecosystem. We'll have modular C++ people and non-modular C++ people, and then the Rust people over there gloating at everybody else. We don't want that.
I think one very positive thing that has come out over like the rewarming of SCG15 over the past few months is that we're seeing like more and more people from like really important projects being more involved with SCG15. I think in the last meeting we had someone from Red Hat, which like from the package management perspective, like having someone from a Linux distribution is kind of important.
Right.
We had Visual Studio, Olga from Microsoft, like in the meeting. Like having Visual Studio in the table is really important if we're talking about converging things. We had CMake, and we have other people that are starting to like be more present on SG15, and I think this is a good sign.
Right. So if you're not involved, fear of missing out, just keep that in mind.
It's like, is it possible Red Hat actually invented the modern package? Like before that, everything was just a tarball? Because
I think chronologically speaking, Debian came before.
Really?
Yeah, I think Debian was created in 93.
And they used Debian. They used packages.
Yeah, you know that Debian is called Debian because it was Jan Murdoch and his wife was called Deborah.
Oh, no.
So it's
That's
Debian.
romantic.
I just thought it was a flashback when you mentioned Red Hat getting involved, because it's my first real job in 97. I actually bought the RPM manual, so because I had to generate some Red Hat packages, and there was no automated tooling for that yet. Anyhow,
there's uneven automated tooling now, so it's better.
Right.
That's kind of what we'd like to see is someday, like if you just ran a, whatever your build system, but I know CMake, so I'll use that. CMake and then CMake install, and you end up with something that looks like a package, and you just tar it up, and you're done.
Right.
And that's where we'd like to get. And I think we can get there. A lot of sticking points these days are about things like Daniel said, like how do we get file systems? Like again, there's no files in the ISO standard. Yeah. If we have the interface, do we want to actually say the file needs to be named this way on this part of the system? How does that work? Sticking points include like, could we do more sophisticated solutions? Gabby Dos Reyes had a really interesting talk at CppCon in October about something called IFC. I can't remember what the acronym stands for, but it has to do with an interchange format whereby you can serialize the abstract syntax graph of a compiler's parsed knowledge of some source code, right, and then save it in a standard format, and some other compiler or tool like an IDE or Clang Tidy or something can go open that up, and without having to do all that extra work, just like walk that graph and decide things. With the ideal outcome being you could write, some Python tree walking code and do interesting source code analysis things without having to actually have like libclang or something linked into your executable, right? It's really interesting. That'd be great for Bloomberg. We'd love for that. We'd love to have that. But again, it's like, do we want to wait 10, 20 years for that to propagate to all the tools we need it to? I don't know, right? Let's start on it, sure, but let's get something else in the meantime, kind of thing. So,
I think Visual Studio can emit that today, I believe. For our for the sake of our listeners here, it might not be production ready for a large scale company like yours, but
no, C++ modules on Visual Studio are implemented in terms of that format.
Okay.
Right. And again, we'd be okay if enough of the ecosystem all got together and said, okay, we're going to sponsor these groups to go add these pull requests to these compilers, and we thought like, hey, we can get this done in 5 years. But,
the challenge that I see there is the reason why the AST changes between different versions of Clang is not necessarily because the C++ language changed, although like if you adopt different standards, you would of course have different abstract syntax trees. But even on the same language standard, from Clang 12 to Clang 11, there are differences in the AST. And the reason for that is, it turns out that there are some niche cases that can't be represented in the AST as it was before. So the AST was adapted to be able to represent those valid C++ use cases. So one other way of thinking about this is that this standardized serialization format would need to go through the same level of rigor that we have on the C++ language when it comes to the lexer and the parser, right? Because you would need to be able to specify to an extent where you say, if it can't be represented by this abstract syntax tree, it's not valid C++.
Mm.
And that's a really, really hard challenge.
Right.
And I'm personally supportive. Like if we want to like move the C++ language standard to include like the standard abstract syntax representation of the language, not just at the level of the tokenizer and the parser, I'm all for it. But it's a substantially big amount of work.
Like the W3C DOM or something.
Yeah.
Yep. A lot like that, actually. Yeah.
Okay. Well, hopefully, some point in the future, build systems, compilers, and everything will converge, and we'll start to be able to get to use modules more. Is there any other changes that we haven't talked about that you're hoping to see from modules, either from the standard or from compilers and build systems?
We need support from the build systems. We are working with Kitware for CMake to support building modules internally first, and then to have support for shipping and consuming module libraries outside of CMake to CMake scenarios, because Kitware is fine just adding more things to the CMake export file, and then if you're consuming from CMake, it's all fine. But we don't really want to have like that tight dependency on everyone using the same build system. So having more implementations on the build system side is definitely important. My expectation right now is that the language feature is fine. I don't think we have any problems today that are caused by the language level specification. So now it's more mechanically how do we make it such that the human can go write code, ship an artifact to another human to consume?
Yeah. On the contrary, we have a lot of problems with that our modules are supposed to solve, right?
Yeah.
So I'd be like really excited if I didn't have to worry about people, setting inconsistent binary important flags across different translation units. That would be fantastic. Like things like how big is your long and things like that, right? There's what I'm talking about, like -d, use this
large file.
Or like here's a fun bit of info. You'll hear a lot of people say that like the standard C++ version is ABI stable, is ABI unimportant, right? You can change your standard, which is actually not true at scale. When you get to a certain scale, which isn't that big actually, you'll find that some libraries start doing feature detection using template metaprogramming, right? Like if you have lambdas available, use this implementation, otherwise use this other implementation, and those will be ABI incompatible implementations. I'm hand waving a lot, right? But you'll see it at a certain scale. You see it already in popular libraries like Abseil, like Bloomberg has something called BDE, which is our kind of analog to Abseil or Boost or something, right? And so those libraries do that, and everybody depends on those libraries. And so all those things are technically ABI unstable, depending on what standard version you set. So point being, for modules, at least you wouldn't have to worry about like that thing, like leaking out a little bit, maybe. Like it seems like that would be moving in the right direction, and we can relax a lot of things.
Preprocessor-based, like preprocessor-driven ABI breakages are going to be way easier to manage after modules.
Right. We'll just have to worry about like within the things that you textually include, is it a problem? Like I don't know how to convert all the things to modules yet necessarily, but assuming we were there, like there's a lot of problems we could solve, and there's problems we could even contain. Like, okay, maybe we can only get half the things modularized anytime soon, but that at least contains those fires to like subsections of the code base or something, right? So, and that's our day to day. I mean, if that wasn't clear, Daniel and I do a ton of like, okay, how do we get all of our code, like including open source code, to do the new compiler or to remove this kind of ABI unstable thing or something?
We didn't have a chance to really talk about ABI. Now we're running out of time.
All right, you can have us back on some other time. We'll talk your ear off about ABI if you want.
Oh, goodness gracious.
I'll say Marshall Cloud's talk was pretty on the nose from our perspective, I'd say. Like when he was on here a while ago about ABI, that's pretty on the nose. just there's a lot of weird edge cases, and at a certain scale, it's really hard. So
it's really easy to underestimate how complicated it is, and
Yeah.
a lot of people think that it's fine to ignore the problems.
It's especially important at the OS level, like because we use like vendor provided, OS provided like compilers and standard libraries, and some low level libraries like zlib, things like that.
Right.
Those things really need to be ABI stable. We build the rest of the world from source in a certain respect. You can check our talk on packaging that Daniel and I did at this October at CppCon about like some enough detail that you can kind of probably guess, like kind of figure out where we're coming from as far as that goes. But yeah, and this is all related. So modules should help. Like in Gabby Does Race talks about, hey, ABI is going to be a lot better if you use modules, and I think he's right. But like, how do we get there? That kind of thing. So.
All right. Well, Bret and Daniel, it was great having you on the show today. Thank you so much for coming on.
Yeah,
Thank
thanks
you for having us.
It's been fun.
Thanks a lot.